Give us the secrets to your chemistry.
Wait a second, I thought you guys were reporters for Fox 31 News.
The Science Lab, and today we are with our scientist, chemist, Christine Wiedinmyer.
Well, actually, I always planned to go to medical school, and I was in college, and I was an engineer, and I chose to be an engineer because they didn't have a foreign language requirement. And if I was a math major, they made me take a foreign language, and I wasn't very good at that. So I chose to go into engineering, and halfway through my engineering degree, I realized I loved the engineering part, and I didn't like the medical biology side of things. So I kept on going with my engineering degree. And when I graduated, I was a chemical engineer, and they usually have chemies go to work for oil refineries and places that I didn't really want to go to. So I chose to go back to graduate school. And when I went back to graduate school, I was lucky enough to find my advisor that I ended up working with, and he did air quality and air pollution research. And from there, I fell in love with the topics that I study and continued going, and was lucky enough to get a job at NCAR, where I work now.
Signing off Fox 31 News with Christine Wiedinmyer. Yes. I'm Candace.
I'm Ozzy.
I'm Esmeralda. I'm Nono. And thank you for watching Science Live. Yeah! And clear!
That's our day job.
What makes you guys think I won't just call security?
Well, you seriously gonna call security on a bunch of middle school students?
How will that look on your record?
Fine.
This is where we keep our plants. We measure the compounds that plants emit to the atmosphere. So you know that pine tree smell that we walk through the pine forest? What we do is we measure those compounds and look at what they do in the atmosphere. So in order to do that, we have to grow trees here, and then we measure them in our lab across the hall to see what they put off and what controls those emissions. So if we increase temperature, will they emit more? If we put more fertilizer on them, will they emit less or more? Etc. And will this plant emit something different than this plant? One thing we're looking at is biofuels. So as we plant more biofuels, we want to see if those kind of plants emit different compounds than, say, a vegetation that would normally be there. Okay? So this is a lab where we actually can measure all those compounds that we smell or collect in the air. So we have all these different instruments. A lot of them are close to the same, where we collect air in a little volume, and then we measure all those compounds that are there in very, very tiny amounts. And when we measure the plants, we actually bring them over into here. This is an environmental chamber. This is a chamber where we can control the temperature and light. And we put the plants in here. We can put the plants into these cuvettes, are called, or little containers. We can put the plant leaves, I'm not sure where the lights are, but the plant leaves in here, put air in and out of it, and we can measure what goes in and what comes out, and we can figure out what compounds the plants are either taking up or emitting into the atmosphere. So this is a nice chamber where we can have controlled experiments as opposed to going out into the real world where things are very variable. And so the air comes out of that, and it goes into this instrument where we can measure those compounds. So these instruments, a lot of the stuff we build actually here at NCAR ourselves. So we have engineers and chemists and physicists working together to build instruments that can measure those compounds. Tell these guys what you're doing.
What's this?
This is Tiffany, another scientist in our group.
Well, if I have to, basically I'm trying to analyze air samples that have been trapped on these little cartridges. We stick them on a pump and we ship them all over the world, and people collect air from forests and different ecosystems onto these cartridges. And they're filled with little pebbly bits of sticky substance that clings on to the chemicals that we want to learn more about. So I basically load them into our special tray, and then I put them into this handy dandy cartridge sampler. And one by one, they get plucked out by a mechanical arm and heated up in an oven. And then all the stuff that's on them gets baked out and goes through a series of tubes and valves, and eventually gets put into a gas chromatograph. The gas chromatograph is kind of like a giant sorting bin where gases travel through a long coil that's like 100 feet long. And because of the chemical properties of the coil, all the stuff, the mixture of gases gets separated into their individual components, and they come out into two different detectors. So we learn about what chemicals are in the samples and also how much of each chemical we have.
Thanks, Tiff.
You're welcome.
Okay, let's feed you later.
Thank you.
Okay, let's go to another lab. Come on this way. This is another lab where we have a bunch of instruments that we measure particles in the air.
Who's that?
Well, this is John Ortega, and he's another scientist in our group. John, tell them what you know.
It's an instrument that measures ultrafine particles in the atmosphere. And normally we measure particles down to 3 nanometers. This one's specifically designed to measure down to 1.5 nanometers.
And how small is that?
Well, the smallest thing you can see with your eye is about 10,000 times greater. It's much, much smaller than that. You could fit, up to 10,000 of these across.
Okay, guys, let's show them how to make clouds. Here you guys go. This is liquid nitrogen, and it's very cold. So when you breathe on it, all the water in your breath condenses and makes cloud drops. Okay, so you need to hold this very still.
So hold it.
And you can make clouds with it by breathing on it. Now do not move and do not leave, because if you spill this, it could burn you because it's so cold. And I'll be right back.
Wait. That's awesome. No, I have a feeling they're not coming back.
For everyone.